Hello everyone. Welcome again to our channel where you can learn anything you want to know. We're passionate about helping you to push your skills to the next league. And to our loyal subscribers, we keep celebrating you for being part of this prosperous family. We urge you to continue watching and liking all our videos. Kindly like this video and subscribe to our channel if you're watching for the first time. We don't want you to miss any of our upcoming videos. In this episode, we'll be discussing about atoms, elements, and compounds. We'll include 1. Atomic structure and the periodic. Concepts under atomic structure and the periodic table are elements, compounds, and mixtures. Atomic structure, electronic configuration, and isotopes. 2. Ions and ionic bonds. In this section, we'll cover ions and ionic bonds, ionic bonds and lattice structure, and the properties of ionic compounds. 3. Simple molecules and covalent bonds. Under this section, we'll cover covalent bonds, molecules and compounds, and the properties of simple molecular compounds. 4. Giant structures. Under this section, we'll cover diamond and graphite, silicon 4 oxide, and metallic bonding.
Elements, compounds, and mixtures. All substances can be classified into one of these three types. 1. Element. An element is a substance made of atoms that all contain the same number of protons and cannot be split into anything simpler. There are 118 elements found in the periodic table. Compound. A compound is a pure substance made up of two or more elements chemically combined. There is an unlimited number of compounds. Compounds cannot be separated into their elements by physical means. Some examples of compounds are copper, 2, sulfate, calcium carbonate, and carbon dioxide. Mixture. A mixture is a combination of two or more substances, elements, and/or compounds that are not chemically combined. Mixtures can be separated by physical methods such as filtration or evaporation. Some examples of mixtures include sand and water, oil and water, sulfur powder and iron filings, among others. Atomic structure. All substances are made of tiny particles of matter called atoms, which are the building blocks of all matter. Each atom is made of subatomic particles called protons, neutrons, and electrons. The protons and neutrons are located at the center of the atom, which is called the nucleus. The electrons move very fast around the nucleus in orbital paths called shells. The mass of the electron is negligible. Hence, the mass of an atom is contained within the nucleus where the protons and neutrons are located. Protons, neutrons, and electrons. The size of atoms is so tiny that we can't really compare their masses in conventional units such as kilograms or grams. So a unit called the relative atomic mass is used. One relative atomic mass unit is equal to 1/12 the mass of a carbon-12 atom. All other elements are measured relative to the mass of a carbon-12 atom, so relative atomic mass has no units. Hydrogen, for example, has a relative atomic mass of 1, meaning that 12 atoms of hydrogen would have exactly the same mass as one atom of carbon. The relative mass and charge of the subatomic particles are shown in the diagram.
Defining proton number. The atomic number, or proton number, is the number of protons in the nucleus of an atom. The symbol for atomic number is Z. It is also the number of electrons present in a neutral atom and determines the position of the element on the periodic table. Defining mass number. The nucleon number, or mass number, is the total number of protons and neutrons in the nucleus of an atom. The symbol for nucleon number is A. The nucleon number minus the proton number gives you the number of neutrons of an atom. Note that protons and neutrons can collectively be called nucleons. The atomic number and mass number of an element can be shown using atomic notation. The periodic table shows the elements together with their atomic, proton, number at the top and relative atomic mass at the bottom. There is a difference between relative atomic mass and mass number, but for your exam, you can use the relative atomic mass as the mass number, with the exception of chlorine.